Hello and welcome. This is Professor Pankaj Kumar, Department of Mechanical Engineering, SRC, Warangal. Today I came with a new topic, that is fused deposition modeling. So in this course, we are going to discuss about what are the fundamentals of the 3D printing process will be there. Those things, as well as I am going to discuss about their process parameters of the 3D printing process. Similarly, I'm also going to discuss about what are the various effect of the process parameter on the print quality. After that, I'm going to discuss about what are the applications, their major advantages and disadvantages about these courses or these topics. So coming to our objective. So basically, after going through this course, you are going to learn about how to define the FDM process. Similarly, you are also going to explain the working principle of the FDM process, and you are also going to identify the major machining component. And after that, also you are going to understand or explain, after going through this course, the process parameter that will affect the print quality. And after that, you are also going to learn about what are the different materials that can be used in this process, their advantage, limitation, and applications. Now we are going to discuss about what are the major classifications of the additive manufacturing process are there. Actually, this classification are done by the different researchers, scientists earlier. As per the major classification, additive manufacturing are divided into the photopolymerization, powder bed system, material jetting system, sheet lamination, material extrusion process, similarly binder jet process, and direct energy deposition process. Further, this classification again divided into subsections, like fat polymerization is divided into two types, like stereolithography, similarly digital light processing DLP, and powder bed fusion process divided into the selective laser melting process, direct laser sintering process or DMLS process, similarly electron beam process or laser beam process. Now coming to the material jetting process, it is also further classified or divided: photopolymer material jetting process or wax jetting process. So similarly, sheet lamination process also again divided into the different categories, like lamination of the metal sheet or making of the product from metal sheet or paper sheet or plastic sheet. Accordingly, this classification was done. Now coming to the material extrusion process, so again it is also subdivided into the fused deposition modeling process, or widely known as the FDM process. And another type is there, fused filament fabrication, that is called as in short, FFF, fused filament fabrication. Similarly, in the binder jetting process, it is further classified as the powder bed based material or liquid bonding agent based material. So similarly, direct laser deposition method, it may be laser based or electron beam based. So these are the major classification given by the different researchers, scientists previously. Based on that, classification are done. Now coming to the classification based on the material state, means based on the type of the material, whether it is a liquid material or solid filament based material or powder based material. Accordingly, the classification are done. So based on this, first is that fused deposition modeling, or FFF, fused filament fabrication process. So this is the most widely used additive manufacturing or 3D printing process. That's why it is the cost effective and versatile process for the various materials. So similarly, based on the material which is in the form of the filament. Now coming to the material in the form of the liquid material, that is raw material will be used as the liquid material. Based on that, classification is called as stereolithography or SLA. So it has the very high precision and a smooth surface finish after 3D printing using of this liquid material. So there are only certain type of the liquid polymer material available till now or developed by the different companies. For that, stereolithography is possible. We will discuss in detail in coming slide about what are those liquid material, how the phenomena is taking place, how from the liquid to solid conversion is taking place. Similarly, also we are going to discuss about the last classification based on the material form or material state is called selective laser sintering process. So mostly in this process we are using powder based material, means whatever it can be metallic based or it can be polymer based material. So if the metallic powder are there, so in that case we are calling the SLM process. So similarly, if here it is the powder like polymer powder based material, in that case we can have sintering process. Yes, selective laser sintering process. So from this type, the strong and durable parts with complex geometry are made. And basically, in additive manufacturing or 3D printing process, the product are made having the very complex shape and size of the product. Now coming to the basic or fundamental fabrication for the 3D printing process, and basically we are going to discuss about the FDM type of 3D printing process. In that FDM process, one can assume that it is kind of the jalebi making process. You maybe have seen the jalebi, how the it is made. So in that they will squeeze and they will press the material, and then the jalebi material will come out and it will fall on the liquid that is a surface. So similarly, this is also 3D printing process, FDM or Fused Deposition Modelling process. In that, what is happening there? So first, filament material will come out coming from the nozzle, that is called the print head. In that print head, it will be having the like a heating element, that using that heating element the filament will be first melted and it will come out through the nozzle. So generally the size of the filament diameter is 1.75 mm. This is the general. Maybe some machine to machine or some 3D printing machine to other 3D printing machine, diameter of the filament will change, but in generally what is the commonly used filament diameter that I am discussing, it is around 1.75 mm diameter. So similarly, and after coming from the nozzle, the nozzle diameter will be the in general commonly used FDM machine having the 0.4 mm diameter. So liquid material will come out from those 0.4 mm diameter nozzle only. So this coming from the solid filament, it will be heated and it will be converted into the liquid material, and it will come out as the liquid material and it will fall on the build platform. So this is the called as the build platform, and this build platform can move in the x axis, y axis and z axis. It depends upon the how machine configuration or development of the build platform are done. Based on that, some build platform are moving in the x coordinate, y coordinate, and separate z axis movement will be there, that heating element can move in the z axis direction. Similarly, in some machine having the feature like it can build platform can move in the z axis direction and heating element can move x direction, y direction, so that all three dimension like x axis, y axis and z axis movement can take place, and the final 3D part can be made from that axis movement. So liquid material will come out from the nozzle and it will fall on the build platform as per the each layer profile. So whatever the profile will be there, those profile I will be discussing in the process and how those happening there, how the process profile will be getting for each layer, particular profile, that will be discussing. So once that liquid material will fall on the build platform, it will be solidified, and after that again next layer will be repeated. In this way, once one layer is printed, after that it will come down by one layer thickness. So similarly, like it is like a similar phenomena like coming out as the fluid rope and takes the desired shape and solidify on the build platform. The molten metal side hot chamber is extruded through the nozzle. Yes, already we have discussed about whatever the filament material will come out through heating element, it will come out the solid filament and it will be heated, and then it will come out as the liquid material from the nozzle and it will fall down on the build platform. After that, solidification will happen. So sometimes maybe support structure will be required, so that support structure will be also generated on the build platform itself before printing if required, if overhanging is there. So in coming class also we will discuss about what is the rules or condition for that. We have to give the support structure and why support structure is required and what are the condition and what is the material from that support structure will be given. So now coming to the additive manufacturing process chain. This is the very important steps in additive manufacturing process, because we know that additive manufacturing will follow different steps. After that only final product will come. So first thing is that first one has to design the part. So whatever the product is required to made, that product design will be done using the some CAD software. There are various CAD software like SolidWorks, CATIA, Creo. Other than that, like Fusion 360, there are various kind of the software available in the market. From that one can design the product, whatever the product is required, and then that design you have to convert into the STL file format. One can ask, sir, why STL file format? Because most of the 3D printing machine will only accept the STL file format. Because of that, you have to convert whatever the file extension of that software will be there, 3D model, that has to be saved in the STL file format. Once STL file format is saved, after that it will be sent for the slicing operation. So during this process itself, here only the slicing will be done. So here the purpose of the slicing will be there to each layer. So suppose one object is made from the 100 mm length and one layer thickness is 0.5 mm only. So for each layer 0.5 mm, so how many layer will be divided? So for each layer, as we know that during the 3D printing process, each layer will be printed at a time only. So after that, again next layer will be printed. Then what could be the height of the one layer, so that our build platform can move in the Z direction, or it can move in the Z direction up or down. It depends upon how machine configuration has done. Based on that, here the slicing will be required. So once slicing is done, so from that slicing one can get the entire profile, means each layer whatever the contour will be there, that contour detail will be received after doing the slicing operation. So what will happen in the slicing operation, the path can be generated, that path having the detail like X coordinate, Y coordinate, similarly the G code or M code, means how it will be rotated clockwise or anti-clockwise. So all detail G code, M code, X coordinate, Y coordinate for each layer will be generated, and each layer as well as the entire profile of the each layer will be generated. After that, one has to save that file, and that file actually will be transferred to the machine in the next step. So what will happen, machine will get the information about the each layer and each profile, what is the X coordinate, Y coordinate at each point. Accordingly our print head will move in X coordinate, X direction, Y direction and Z direction. Once the file transfer is taken place in the machine itself, the file, yes, this is one of the another things one should know about how the file can be transferred here. So file can be transferred using USB drive, or if you have done the slicing operation in the machine software itself, those software provided by the company itself, those company making the 3D printing machine itself, or sometimes one can be used like open source software like Ultimaker Cura software. So Cura software can be like it is open source software, one can use for the slicing operation, and one can understand about what is the total consumption of the material for the entire object, how much time duration it will take. Similarly, the one can know about the what is the file size. So this all setting will done during this slicing operation. After that, those file once saved, so that file has to be transferred into the machine using USB drive, or if it is the software in the same like software machine software itself, then only has to transfer from one like operation to the next operation. After that, what you have to do it machine setup. So in the machine setup, you have to load the material. So what is the filament material you are using? Suppose the FDM based material, one can use the ABS material, PLA material, or maybe some other material like PEEK material, PEEK material, or it can be TPU material. There are various kind of the filament material available for that. One can use the filament material. So those filament material loading as well as the machine setup include like a parameter of the, or a printing parameter, like what is the scanning speed, what is the layer height thickness. So similarly, the power is on or not. This all will come under the machine setup. Once the machine setup is done, after that what you have to do, then one has to start the switch on the machine, and then it has to be started like printing. So once printing is started, so main power is not required to perform any operation there. Just only surface observation, whether the machine is working properly or not, power is on or not, or similarly material is there or not, or totally consumed material. So this for the surface observation purpose only main power has to be there. Otherwise, no use of the any person has to be there. Once the print is done, after that what you have to do, part has to be removed from the build platform, and maybe sometimes we require post processing operation, maybe improving the surface quality, removal of the like support structure. Once this all secondary operation done like post processing, after that, that final product will be there. That final product can be sent for the customers, those who have given the order, or can be used by the users itself. So these are the called as the process chain of the additive manufacturing. Here I have given the some schematic representation of the actual product which is can be manufactured. So first we have made the CAD model of the whatever the final part is required. So similarly, after that, that CAD model will be transferred to the STL file format, and there slicing operation will be performed, and from that slicing operation one will know about the complete detail about the each layer and like each contour profile for that particular layer itself. After that, it will be that file has to be transferred to the machine, and then once machine transfer is done, after that you have to start the printing. So here you can see that printing is happening there. After that, one can see that part will be printed, and so this is the final product is printed on the build platform, and from that build platform one has to be removed. The part has to be removed from the build platform for the actual operation, or you can say that maybe secondary operation like post processing. So this is the post processing operation. After that, it can be sent for the customers, or maybe directly used for the where the part application are supposed to use it. So this is the part which is made for the holding for the stepper motor. So a stepper motor is mounted on this additive manufactured part. So these are the process chain of the additive manufacturing process. Now coming to the what is the basic difference between the additive manufacturing and the subtractive. machining process. As we know that additive manufacturing means layer upon layer development of the material will be taken. Material can be liquid material, can be solid filament material, or it can be powder based material. So how much material consumption is required, what is the profile of the design, as per there only material will be deposited on that particular layer, so no material wastage will be taking place. But now you can see that in the bottom, so raw material can be, here I have given the one case for the having the raw material in the form of the powder. So whatever the profile of the CAD model will be there, or part will be there, so wherever the will be there part design, there only directly deposition will be taking place, and layer upon layer. After that you can see that this is the final product. Only a small amount of the wastage will be there. Those wastage will be coming in the form of the support structure. Sometimes, as we have discussed about, the support structure is required. So that support structure ultimately it will be not part of the our entire object. So that has to be removed in the secondary operation. Yes. So those has to be completed, and that only wastage of the material will come. Otherwise, no wastage will come. Now coming to the subtractive material removal process, you are starting with the bulk size of the material, and from that bulk size, unwanted material you have to remove to get the final shape and size of the product. So this is our final shape and size of the product. For getting this profile, you have to remove the whatever the extra material beyond this profile will be there. So you have to perform so many operations during the subtractive machining process, manufacturing process. Subtractive material removal process is nothing but the machining operation. One can perform the lathe operation, one can perform the milling operation, or one can perform the other material removal process. So this way, final product thread printing, final product we can manufacture using subtracting manufacturing process. So during this, one can see that here lot of material has to be removed, and that material will go to the wastage only. That's why lot of wastage will come in the subtractive manufacturing process, or you can say that material removal process or machining process. Now coming to the what are the major key component of the FDM process are there. So coming to the left side diagram, so various component like build platform, as earlier we have discussed about, the printing will happen on the build platform only. Whatever the liquid material will coming out from the nozzle, that will be deposited on the build platform, so that we have to give the some heating also. That's why I have mentioned here the heated bed. As we know that nozzle material will be coming out in the form of the heating only, so that's why we have to give the some heating or elevated temperature to the print bed. Otherwise, maybe sticking to the build platform, maybe not taking properly. Because of that, maybe sometimes warpage and some defects are coming. Similarly, it can be like foam base. Now coming to the material spool. Material spool is nothing but the wire filament will be spooled over that spool itself, and then it can be build spool material, or it may be support structure material. As we know that it can be final product part which is made from that material, as well as sometimes we require support structure for that. Sometimes maybe same material can be also used for the support material, or sometimes we can use the different material as the support material, so that sometimes it is advantageous in the form of you have to perform secondary operation to remove the support structure material. Sometimes if you are using dissolvable material, so that dissolvable material, once it is kept into the some chemical bath, in that bath itself it will be dissolved, so much effort will be not required, and even one can get the good surface finishing if the chemical phenomena will happen for the dissolving. But if you are performing some plier, you are using some plier and you are removing, so what will happen, that rough surface will come out. So ultimately again you have to perform the finishing operation to get the better surface finishing on that joint area. That's why the different support structure material and the main building material will be required. So that is advantage. Similarly, the drive wheels is required because as we earlier we have discussed about our build platform can move in the x direction, y direction, as well as the print head can move in the z direction. For that, giving the x motion, y motion, z motion, we require drive motor. That drive motor will rotate, and accordingly the how much length in x direction, y direction and z direction is required, that much drive it can give. So similarly, it can be motor based or gear based. Similarly, liquefier is nothing but the heating element. This is the heating element will be there, so that liquid in that filament will be heated and then it will be converted into the liquid material. So in that heating coil will be there. So similarly, some temperature sensor will be there. So how much temperature is required to perform that temperature will be generated by the temperature. One can observe what is the temperature of the build platform is there. Those things as well as everything we can get it. Now coming to the other things like other part like design and the functionality. Similarly filament, what is the filament material is required. So similarly the extrusion based heating element. So similarly the extrusion nozzle will be there. This is also very important part of the a 3D printing process will be there. In that, what is the nozzle diameter, similarly what is the material flow rate will be there. Means in that nozzle material will be getting heated and it will come down and then it will be heated, so that part will be manufactured coming out in the form of the liquid and it will be deposited on the material. So after that, now in the right side image you can see that this is the filament. This is the a spool will be there. On that spool filament will be roped over, and then that filament will be supplied through the nozzle and it will be heated using the heating element. So similarly for the motion of this filament, we require some drive motor. So that drive motor can be used. So this XYZ motion. Similarly, the this is build platform. Over that build platform, this part is fabricated and the build platform can move in the X direction, Y direction and Z direction. Now coming to the process parameter, this is also very important aspect of the 3D printing process. So the first thing is that layer height. Layer height is nothing but the each layer, what is the thickness, that thickness will be called as the layer height. So similarly it can vary from 0.1, 0.2, 0.4, 0.5, not more than that. Otherwise, if you are increasing the layer height, so what will happen, the one can get the printing in less time, but the quality of the surface will get down because layering effect will come. So to avoid that, one has to keep the optimal value of layer height, thickness. So similarly other parameter like nozzle temperature, what is the temperature in the nozzle, from that one can know about that what is the heated material temperature which is coming out of the nozzle. Similarly bed temperature, as earlier we have discussed about the bed temperature is required, so that during the falling the liquid material on the build platform, so it will be properly joined on the build platform or solidify on the build platform. Otherwise solidification defect will come. Similarly, what is the nozzle diameter, then what is the printing speed, then infill pattern. There are various kind of the pattern will be available. In the coming classes we'll be also discussing about the what is the infill density, infill pattern, infill profile. Similarly the cooling fan speed. So sometimes we require, as we are using the heating element, so that system will be getting heated. So for that we require cooling fan, so that optimal temperature will be maintained for that heating element. Then build orientation, maybe sometimes a part will be printed in the horizontal direction or it can be printed in the vertical direction. For that build orientation is required. Maybe there are different angles, from that angles one can. So similarly support structure setting will be there, then retraction distance. So these are the major process parameter of the FDM process. Now coming to the various, these are the various part which is printed using FDM process. Now you can see that these are the tool path generated during the slicing operation, and these are the final product using FDM process. And this is also, you can say that here the sample part, like either in that support structure are printed, and after the secondary operation one has to be. Yes. So now coming to the what are the commonly used FDM material. So first is that PLA material. So it is coming in the form of like soft grade, hard grade, depends upon the application of the part. So which part is required to made, what is the strength, hardness and other mechanical properties. Based on that one can decide the whether to use the soft grade material or hard grade material. Similarly, coming to the other PVA material, it can be dissolvable material or it can be like a support material. So similarly, the soft PLA material also available, like rubbery kind of the material. Similarly, flexible material. Similarly, polycarbonate material having the feature like high temperature nozzle material. Similarly, strong in nature will be there. So similarly, ABS material, commonly used material, and it has durable. So these are the some of, only I have mentioned about the some of the commonly used material. Various other kind of the material also available. So thank you everyone for listening. Thank you.